Hello students, welcome back to my channel. This is Nipa Patel from the Math Masters, and in this video we are going to start chapter 1 Relations and Functions exercise 1.2. Please like the video and subscribe to get the notifications for the new and upcoming videos. Let's begin. Exercise 1.2 question 1, show that the function f r star to r star defined by f of x equals 1 over x is 1 1 and onto where r star is the set of all non-zero real numbers. So that's why they didn't use r. Why? Because it is a little bit different than real number set. It does not have 0 in it. Is the result true if the domain r star is replaced by n with codomain being same as r star? Okay, so actually you got two questions in here. One question is still here. So first we are going to do this much and then we are going to tackle this last part of the question. You can assume that this is r asterisk or you can call it r star to r star. Doesn't matter that much. So let's do this first part first. You are given from r star to r star. So that means domain is r star, codomain is r star. That means domain is this and codomain is this, and you are given what function definition? F of x is equal to 1 over x, and you need to show that it is 1 1 and onto. Okay honey, show that the function f defined by f of x equals 1 over x is 1 1 and onto. That means we are given that that function is 1 1 as well, that function is onto as well. We just need to prove that that function is 1 1 and onto. Now since we have to prove it, we cannot use some counter example because there is none, because it is correct. So you won't be able to find counter example, so we'll have to literally prove it. So let's start with proving 1 1. So to prove 1 1, you always start with picking two elements from domain. So let's pick two elements from domain and let's call them x1, x2. Let's call them x1, x2. So let x1, x2 belongs to r star. Here I am talking about domain, because to prove 1 1 we pick two elements from the domain and then we find the function value for that both elements. So f of x1, now f of x is 1 over x, so f of x1 is going to be 1 over x1, and then we do the same with f of x2, it's going to be 1 over x2. Now we assume that both the output, both this f of x1 and f of x2, they both are same. We are going to assume that this both are same, and if they both are same, that means this must be same as this. So 1 over x1 is equal to 1 over x2, and when you cross multiply you are going to get what? X2 is equal to x1, or I can write x1 is equal to x2. As soon as you get x1 equals x2, you can conclude that f is 1 1. So the procedure of proving a function is 1 1 is what? That you need to take two elements from your domain and then use your function definition, find the function value at that x1, at that x2, and then assume that they both output are same. So when you assume that the both output are same, and then if you end up getting that those output are same only when those x1 and x2 were actually the same values. So that means every input has distinct output, or other way around, every element in your codomain has distinct pre-image in your domain. That means that function is 1 1 because one element is connected to 1, or other way around, one element in that codomain is also connected to only one element in domain. So just 1 to 1. So that's why the name is f is 1 1. Okay, what do we need to do to prove 1 1? Always start with two elements in domain, then find your f of x1 and f of x2, and then assume that they both are same. And if they both are same, you make this and this equal to each other. And while simplifying, if you end up getting x1 is equal to x2, that means you have showed that that output is going to be same only when both the numbers are actually same. That means the function is 1 1. So this we have proved that that function is 1 1. Now we are going to work on onto. Now onto. So for that onto, a function is onto when, like, if I try to draw that diagram of domain and codomain, this is our domain, this is our codomain, and function goes this way, f of x equals 1 over x. So 1 1 means what? Like, exactly 1 connected to 1, exactly some value is connected to some value, exactly some value connected to some value. So if when 1 here is connected to only one value here, and other way around, only one value here is connected to only one value here, that way we can say that function is 1 1. But onto means what? That every element in here must be connected to some pre-image in here. You cannot have some spare element in here. So here your domain was r star, codomain was r star. So every number that you can imagine in this, all real numbers but 0, because it says what? This domain and this codomain, they are real number set, but they cannot be 0. So it doesn't have a 0 in it. That's why it is not r, but little bit different name, r star. So all the elements in this codomain must be connected to something in this domain. And as soon as we prove that, then we have proved that that function is onto. So for that, we are going to pick one element from here. So let's say that this element is y. Okay, we always take our y value as output value, and that is nothing but our codomain. So let's assume that y is the member of r star, which is our codomain. Okay, so we are taking one element and calling it y, which is in our codomain. Now if y is in the codomain, and see, function definition is 1 over x, so that means there must be some x in here, there must be some x in here whose reciprocal, whose 1 over x was equal to y, because that's what the function definition is. So if there is a y which belongs to codomain, then y must be equal to 1 over x. Why? Because that's what the function definition is, and f of x is generally our output. So you can think that way as well, that f of x is nothing but y, so y equals 1 over x. Okay, now when you get y equals 1 over x, I want you to solve this equation. Right now it is solved for y. I want you to solve this equation for x. So if you try to solve this equation for x, you are going to get what? X is equal to 1 over y. And does this belong to r? Yeah, it belongs to actually r star. Why? Because y cannot be 0, right? Y cannot be 0. But yeah, r star does not have 0 in it, because all non-zero real numbers. So yeah, of course, this belongs to r star. So of course, we can say that if you pick a y here, then you must have a pre-image in this domain, which is proved here. See, x equals 1 over y, and that is possible. You can find this value in that domain set. This is our domain. So yeah, 1 over y you can find in that r star, and yes, that means it is onto. But just to show little bit more, you are going to do what? Function f of x was what? 1 over x, right? Now you just found that you just found that x is equal to 1 over y. So you are going to plug in that 1 over y instead of this x. And as soon as you do that, see, 1 over. Now instead of y, we are going to plug in this 1 over y. So 1 over 1 over y, it's going to be y. And as soon as you show that f of x is equal to y, that means you are done. That means function is onto. Always remember that. To show onto, you need to pick one value from your codomain, then use your function definition and try to solve that for x. And then in your function definition, try to plug in that x. If you plug in that x and if you end up getting f of x equals y, that function is onto. So this function, the first half part of this question, we are done, that this function is 1, 1 and onto when the domain is r star and the codomain is r star. Now in the second question, they have changed what? That is that result is still going to be true if the domain r star is replaced by n and codomain being the same r star. So instead of this r star, now in the second question we are going to take n as our domain. So let's do that here. Now our domain is n and our codomain is r star. Right now, since you know natural numbers, they are going to look like 1, 2, 3, 4, 5, 6, keeps on going. This is real number set. So every number that you can think of, every decimal, every negative, every positive, every fraction, every rational, every irrational number, but not that 0. So other than 0, write down every value. Negative 3, negative 2, negative 1.5, 1, 2, 3, 6, 10, and keeps on going both ways, right? Because it is real number set such a way that there is no 0 in it. Now, so if I try to write that function, the domain is n, so n goes to r star. Here we had what? R star to r star, right? Domain and codomain. Here we will have what? N to r star. This is domain and this is codomain, because that's what we were given, that we had to change our domain to natural number set in this part. Function definition is still same. F of x equals 1 over x. Now 1 over x, so 1 over 1, it's going to be 1. So 1 is going to get connected to 1, of course, right? Now 2, that means 1 over 2. And yeah, you must have 1 over 2 here. It is real number set. So yeah, you let me add that 1 over 2, and 2 is going to get connected to that value. 3, 1 over 3. So it's also going to get connected to that. Or let me just write those down so that makes even more sense. Because this is real number set, so it will have all those values. So let me write 1 there, let me write 1 over 2, 1 over 3, 1 over 4 and few more. So 3 is going to get connected to 1 over 3, 4 is going to get connected to 1 over 4, because that's what our function definition is. Function definition, f of x equals 1 over x. So if you pick 1, then 1 over 1. If you pick 2, then 1 over 2. If you pick 3, then 1 over 3, right? So looks like, yes, this is going to be 1, 1, because see, one element is connected to one element from this way as well, from this element to connect it to just one element only. So it is going to be 1, 1, and when it is 1, 1, we need to prove it. We cannot just show the counter example. So 1, 1. So we are going to do what? Again, same way. Let x1, x2 belongs to our domain n. Now I'm not writing n because domain is n and codomain is r star. So you'll be able to know for which set I'm talking about. So I'm taking x1 and x2 from this domain n. Now if x1 is in n, that means f of x1 is going to become 1 over x1 and f of x2 is going to become 1 over x2. Now we assume what? That both output are same. And then we plug in these values that we just got. So 1 over x1 is equal to 1 over x2. That means x1 is equal to x2. And see, we started with assuming that both output are same, and we ended up getting that they are same only when the input are exactly same. So f is 1, 1. So function is 1, 1. So we already showed that this function is 1, 1. Now on to. Now if you see here that negative 2. So 1 over x, or this negative 2, does this negative 2 has any pre-image in here? How will you get your answer as negative 2? So you can think here that 1 over x is equal to negative 2. It's going to happen when your x is equal to negative 1 over 2. But we don't have that value in here. See, this is natural number set. This is natural number set. Or let me tell you this way, that 1 over x must be equal to what? Negative 2. So that x, if that x is negative 1 over 2, then yeah, it's going to be negative 2. Why? Because 1 divided by negative 1 over 2 is negative 2. So that means our input must be this. An element in this domain must be negative 1 over 2. Then and then negative 2 is going to get occupied. Negative 2 has a pre-image negative 1 over 2. But this is natural number set. So it won't have that number in it. And as soon as we find even just one free element, that function is not onto. And here we have infinitely many numbers which does not have any pre-image in this domain. So we are just going to give the counter example, because when it is onto, then you have to prove it, but when it is not onto, that means you just need to show that counter example. So here we are going to show this negative 2, right? Because negative 2 does not have any pre-image. You can even say negative 1 as well, because negative 1 was also in here. So negative 1's pre-image must be negative 1, and we don't have negative 1 in here because it is natural number set. So negative 1 is also free. No, it's not connected to any element in this domain. So that is one more counter example. So whatever you want to write, you can. It just be one counter example that you are supposed to show. So negative 2 belongs to R star, but negative 2 has no pre-image in natural number in our domain. Therefore, f is not onto. We were supposed to do what? We were supposed to do this two parts. In first part, we were supposed to show that it is 1, 1 and onto, which we already did. See, it is 1, 1 and that function is onto. After that, the second part was what? Now change your domain to natural number n and see is that result is still true. So we changed it to natural number and we saw that that 1, 1, yeah, that was still true, that this function is still going to be 1, 1, but onto, no. So function is not onto when you change that domain from R star to natural numbers. Question 2. Check the injectivity and surjectivity of the following functions. And part 1, the first question in that is f from n to n given by f of x equals x square. So first of all, what is injectivity? Injectivity means if a function is 1, 1, then it is injective function. And surjectivity means if a function is onto, then it is surjective. So these are just different words for 1, 1 and onto. 1, 1 is same as injective, surjective is same as onto. Now you are given what? Function from natural number to natural number. So let's say this is our domain and this is our codomain. This is our domain and this is our codomain. Since it is natural number, it's going to be 1, 2, 3, 4, 5, 6, 7, 8 keeps on going. Again same way 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 keeps on going. And function you are given is what? F of x, and the definition of that function is x square. So you need to do square of it to find the image in codomain, right? So 1 square of 1 going to get connected to 1. 2, so that means square of 2 going to get connected to 4. 3, that means square of 3 is going to get connected to 9. 4 going to connect it to 16. 5, 25. All those numbers are there, but I couldn't write it because there are like infinitely many numbers in here. But you guys got the idea that it's going to get connected this way. So since one element from here is connected to one element in here or other way around, one element in here or every element in codomain has a pre-image, only one, a unique pre-image in domain. So this function is 1 1 function. So definitely this function is 1 1. Now what about onto? See, this 2 does not have a pre-image, 3 does not have a pre-image, because you cannot find a square root of 3 in natural number set. You cannot find square root of 6 in natural number set, right? So many, infinitely many numbers are in here in codomain which does not have any pre-image in this domain. So we can say that this is not onto, is 1 1 but not onto. Now we just need to prove that. So first we are going to start with 1 1, that means injective, because 1 1 injective same thing. So always to show 1 1, since it is 1 1 we are going to prove it. This function is 1 1, so we are supposed to prove it, and to do that we are going to take two elements in this domain, and let's call them x1 and x2, which belongs to n. In here I am talking about domain. Now if x1 is in domain, then if I plug in x1 from this function definition, x square, I am going to get what, x1 square. If I am going to plug in x2 in the function definition, I am going to get x2 square. Why? Because function says what, whatever you plug in, it becomes square of it. So if you plug in x1, if your input is x1, it's going to be x1 square. When your input is x2, it's going to be x2 square. Now let's assume that f of x1 and f of x2, they both are exactly same. That means we are assuming that input x1 and input x2, they both are connected to the same value in codomain. And we just found that f of x1 is what, x1 square, and f of x2 is what, x2 square. So when this thing is going to happen, that square of x1 is equal to square of x2. So that is only going to happen when your x1 and x2 are same. I can add plus minus here if it was integer set, but here it is natural number set, so there is no minus sign in here, there is no negative number in here, so I am not going to add that plus minus here. So x1 square equals x2 square is only going to happen when your x1 is equal to x2. So when x1 is equal to x2, of course they both will have the same output. So of course this function is what, f is 1 1, or you can say f is injective, right? We always start with two elements in domain, then we find f of x1, we find f of x2, and then we start with assuming that they both are same. F of x1 is same as f of x2, and then we plug in this, and then we see that do we get x1 equals x2. If we get that, then that function is 1 1, that function is injective. Now we are going to show onto. Now is this function onto? We just have discussed little bit in this diagram, and we clearly saw that this function is not onto. And when the function is not onto, then we just need to show a counter example. So here we can take this 2, because 2 does not have any pre-image. So we are just going to say what, 2 below, we are just going to say what, that 2 belongs to n. In this case we are talking about codomain. So 2 is here in this codomain, but it does not have any pre-image in this domain, so this function is not onto. But 2 has no pre-image in domain n, therefore f is not onto, or you can say f is not surjective. Now second part of this question, again we need to check for injectivity and surjectivity for this function given is from integer to integer. So let's say you got a domain and you got a codomain from z to z, and that function definition is f of x equals x square, and since it is z, that integer function, so it's going to be like -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, and keeps on going. Same way here as well, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, keeps on going, right? So when your function definition is x square, let's see where it goes. See, -3. -3, if you do square of that, -3 square is 9. So it's going to go to 9. Now -2. Square of -2 is going to be 4. So it's going to go to 4. Now -1. Square of -1 is 1. So it's going to go to 1. Square of 0 is going to be 0. So go to 0. Square of 1, it's going to be 1. See? So -1 went to 1 and 1 also went to 1. So it's definitely not injective. It's not 1, 1. Why? Because if you keep on doing this, the 2 is going to meet to 4. Then 3 is going to go to 9. So -3 and 3 will have same y value. -2 and 2 will have same y value. -1 and 1 will have same y value. Same way, -4, 4, -10, +10, -100, +100. They all will have same values, both negative, so both opposite number will have same x square value. So this function is not 1, 1. So if we start with 1, 1, means injectivity, means that function is whether injective or not. Let's do 1 and -1. So why let, it's already there, right? Okay, so 1 and -1 belongs to z, the domain, and f of 1 is going to be 1 square, going to be 1, and f of -1 is going to be -1 square and again 1. So even though that f of 1 is equal to f of -1, 1 is not equal to -1. So f is not 1, 1. That means f is not injective. Okay, now we will check for onto. Okay, so now we'll check for onto. So to check for onto every image in Z, if that every number in this codomain, if all those number has pre-image in this domain, then yes, this function is onto. But does that happen? See, -3. Whose square is -3? None. So all those negative numbers are going to be spare, like they are just lying there. They are not used by this domain. Even 2, even 3, even 5, even 6, 7, 8. So not all numbers of this codomain has pre-image in this domain. So this function is not onto. So we are going to say what? That -3 belongs to Z, and in this case codomain, but -3 has no pre-image in domain Z, therefore f is not onto, or you can say f is not surjective. Question 2, third part. You are given a function from R to R given by f of x equals x square. So your domain is real number set and your codomain is also real number set. and this function from this R to this R, that means from domain to codomain, that function is f of x, and that is equal to x square. Now since it is real number set, we know the numbers are going to be like -3, maybe negative square root 5, 0, 1.2, 1, 2, 2.5, 3, and like many more, because all the real numbers that you can imagine, they all are here in this domain. This is your domain and this is your codomain. Now this is also the same set, again same real number set. The codomain is also R. So again -3, -2, 0, 1, 2, 3, 5, 6, 7. Even though I'm skipping few, that doesn't mean that those numbers are not there in real number set. They're all, any number that you can think of, any real number that you can think of, it's there in this codomain. Now since the function definition is f of x equals x square, so if I want to draw the relation between domain to codomain, so square of -3, so let me just add 9 in here. So square of -3 is going to be 9. So the relation is going to become from this -3 to 9. Now negative square root 5. So square of this is going to be 5. Square of 0 is going to be 0. Square of 1 is going to be 1. Square of 2 is going to be 4. So I just need to add 4 there. But yeah, you got the idea that what I'm trying to do. So now if I had -1 here, then square of -1 is going to be also what? 1. So square of 1 was 1, square of -1 was also 1. Same way, square of 2, square of -2, square of 3, square of -3, square of square root 5, square of negative square root 5, they are all going to be same, right? So that means this function is definitely not 1 function. So let's first talk about this 1 So in this 1 we are going to say what? That -1 and 1, this both belongs to R. We can see -1 in here, we can see 1 in here. We know they both are real numbers, so they both are going to be in this domain. Now -1 and 1, they both are in R, and from this function definition, the function definition is what? That f of x is equal to x square. So if I find f of -1, it's going to be what? -1 square, it's going to be 1, and f of 1, square of 1 is also going to be 1. So we saw what? That f of -1 is equal to f of 1, even though -1 is not equal to 1. So when this happens, that the function value of -1 or function value of some number and function value of some other number, they both are equal, but those input, those x values, those domain that you are finding that function value with respect to, those numbers are different, then that function f is not 1 function. So this is the reason why this function is not 1 now. And since it is not 1 see, they use different word for that. They ask that you need to check the injectivity. So since f is not 1 means f is not injective. Okay, so 1 done. Now we need to check for surjectivity. So that means onto function. So now we are going to talk about onto. Now onto means what? A function is going to be onto when every member of this codomain is occupied with some pre-image in this domain. So look at this -2. -2 is square of what number? No number, right? Because you can not have a negative number as square of something. So all the numbers which are negative in this real number set, you will never be able to find a pre-image in this domain. So since we cannot find the pre-image of this -2, so -2 belongs to R, but -2 has no pre-image in domain R, so F is not onto, or you can say F is not surjective. Okay, so we found that this given function is not injective and this function is not surjective either. Now, fourth part of this question. Again, you need to check injectivity and surjectivity of the following functions. And now we are doing this fourth one. And here you are given that your function is from natural number to natural number. So from n to n. And that function you are given is from domain to codomain as f of x equals x cube. Now, since these are natural numbers, let's list few of them. So it's going to start at 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's going to keep on going. Again, same here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, it will keep on going, right? So from this function definition, f of x equals x cube. So 1 is going to get connected to 1 cube, 1. So 1 is connected to 1, 2 cube. So it's going to be 8. So 2 is connected to 8. Now 3 cube. So it's going to get connected to 27. 27 is somewhere here because these are natural numbers. So all the numbers that you can think of, all the whole numbers that you can think of other than 0, they are all going to be here in this natural set, and you will be able to find the cube for every number because this goes up to positive infinity. So, of course, this function is 1, 1. Why? Because 1 is connected to 1. 1 is not connected to any other number. 2 is connected to 8 only. 2 is not connected to any other number, or vice versa. So, this function is definitely 1, 1. And if you look at this codomain, see, bunch of values are not preoccupied. This bunch of value does not have a pre-image in this domain. So, it's not onto, because to become onto, every element must have a pre-image in this domain. Okay, so that doesn't happen here. So it is 1, 1 but not onto. Now we just need to prove that. So let's start with 1, 1. So to prove that, we always take two elements from this domain. So let x1, x2, they both belong to n. Both are n, so I am going to just say that this n, we are talking about domain. We are taking x1 and x2, two elements from the domain. And from the function definition, we can say that if f of x1, then you plug in x1 for x and you are going to get x1 cube. And for x2, you are going to get x2 cube. Now, you start with assuming that output of f of x1 is same as output of f of x2. And what was that? F of x1 was x1 cube and f of x2 was x2 cube. And this is only going to happen when your x1 is equal to x2. And since you prove that this output are going to be same only when your values are exactly same, when you are talking about the same value, then and then those outputs are same. So that means you have proved that the function f is 1, 1. Now we need to show onto. Now we won't have to prove this way. Why? Because this function is not onto. So when it is not onto, you just need to show a counter example. So here, let's look here. 2 is not occupied. 2 doesn't have a pre-image in this domain. So we are going to say what? That 2 belongs to, we don't need to say let because 2 is already there. So 2 belongs to n. Here we are talking about codomain, and 2 is there in this codomain, but 2 has no pre-image in domain n, so f is not onto. Here we were supposed to check for injectivity and surjectivity, so we are going to state here that so f is 1, 1 means f is injective. Why? Because other name for 1 1 is injective and other name for onto is surjective. So F is not onto means F is not surjective. Now fifth part of this question 2. Here we are given function from integer set to integer set from z to z given by f of x equals x cube. So if we look at the diagram, then let's make it this domain and this is our codomain. Function goes from here to here, so that is f of x function and definition is x cube. And since it is integer set, so it's going to have all bunch of values from negative infinity to negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5 and keeps on going till positive infinity. Here same, but I am going to write little bit different values so that we can find the relation from this to this because it is x cube. Otherwise they both are exactly same. They have exactly same values because they both are what? Integer set. So bunch of values from negative infinity, then negative 27, again few more values, negative 9, again few more values, negative, okay, yeah, let's keep negative 8. So no values in between negative 9 and negative 8. So negative 9, then negative 8, again few values, negative 1, then 0, then 1, then 2, then again few more values, then let's say 8, then again few more values, 27, again few more values, 64, 65, and it keeps on going till positive infinity. So these both are integer set. They both have all the integers in it. Now if we look at this function definition, that it is x cube. So if you do cube of this element in this domain, negative 3, cube of negative 3 is going to be what? Negative 27. So it's going to get connected to negative 27. Now if it is negative 2, if the input is negative 2, then if you plug in into here, it's going to be negative 8. So this is going to get connected with negative 8. Negative 1, x cube of that, so that means negative 1 cube is going to be negative 1. Cube of 0 going to be 0, cube of 1 going to be 1, cube of 2 is going to be 8, cube of 3 is going to be 27, and so on. So looks like every input, every element in this domain has distinct output. Like negative 8 from here is connected to only one value here, or vice versa, that negative 2 is connected to only one output in here. So this function is clearly 1 1. Now is this onto function as well? To become an onto function, you must have every element of codomain occupied with some element in domain. That means every element in codomain must have some pre-image in this domain. See, negative 9, not a cube of any integer. So we cannot find a pre-image for negative 9. Same way negative 6, same way negative 2, bunch of, like infinitely many integers are there which are not occupied from this codomain, which don't have any pre-image in this domain. That means this function is 1 1 but not onto. This is 1 1 but not onto. Now we just need to prove that we need to check the injectivity and we need to check the surjectivity. So we just need to prove that it is 1 1, and since it is 1 1 we'll have to prove, but since it is not onto, we are just going to give some counter example and we'll be done with that. Okay, so let's start with our 1 1. Now to prove that a function is 1 1, we always do what? We take x1 x2 from domain. So we are going to take, let x1 x2 belongs to z. Which z? Domain. And since function definition is what? F of x equals x cube. So f of x1 is going to become what? X1 cube, right? And same way, f of x2 will have what value? X2 cube, right? Because of that x cube definition. Now we are going to assume that both values are same. F of x1 is equal to f of x2. That means this must be equal to this because that is the value of f of x1 and f of x2. So this means x1 cube is equal to x2 cube. And now this is only going to happen when x1 and x2 they are actually same number. So as soon as we prove that whatever two numbers we started with, they both are actually same, when the output are same, we are actually proving that the function is 1, 1. So the function is 1, 1. Now we need to, and yes, we had to use that injectivity word. So we are going to say what? If a function is 1, 1, that means that function is injective function. So I'm just going to say what? So f is 1, 1, or in other words, f is injective. Okay, the other name for 1, 1 is injective. So if a function is 1, 1, then of course that function is injective because they both are actually the same meaning. Okay, now we are going to prove that that function is not onto. Why? Because we already seen that diagram from domain to codomain, that relation also we have established, and we found many values which are in codomain and they don't have any pre-image in the domain. So we are just going to pick one in here and we're just going to write that that number does not have any pre-image. So in this case, see, this 2 does not have any pre-image, right? 2 is not connected to anything in here. So we can write that let 2 belongs to Z. In this case, we are talking about codomain. And what did we figure? That that 2 does not have any pre-image, but 2 has no pre-image in domain Z. So F is not onto. And other word for onto is surjective. So F is not surjective. Right? That's what we were supposed to do. Check the injectivity and surjectivity. So we checked. So it is injective, but it is not surjective. Okay, so that's it for this video. Please remember to like and subscribe. See you all in the next video. Thank you.